Now let's solve find all numbers disappeared in an array. In this problem, we're given a nums array, which contains numbers within the range 1 to n, where n is the size of our array. So we have a nums array that consists of all the numbers including 1 all the way up to n, so also including the size of our array. And what we need to do is we need to return a list of integers of all the missing numbers that do not appear in this range. So in other words, in this example, we have 1, 2, 3, 4. As you can see, we don't have a 5, and we don't have a 6, and we have a 7, and we have an 8, so we need to return 5 and 6. Now, although this problem is classified as easy, if we had to answer the follow-up question where we have to solve it without extra space and an O of n runtime time complexity, then this is arguably a medium question, but nonetheless, we're going to solve it in an easy, understandable way. And also, they say that although we need to solve it without extra space, what that typically means is that we need to use the same array or list that they gave us instead of creating a new one with our answers in it. But they say that you may assume the returned list does not count as an extra space, so we can create our own list of integers, store the numbers that don't appear, and return that, and we'd still abide by the without extra space constriction. So the way we're going to solve this is we're going to use the array itself as a map to remember which numbers we've seen by marking their corresponding indices. So the way we're going to solve this is by using the array itself as a map to remember which numbers we've seen. And how are we going to do that? We're going to do that by marking their corresponding index positions as negative. So what do we know? We know that all the numbers in our nums array are going to be between 1 and n, and there are going to be duplicates since we have some missing numbers. So in other words, some numbers may reappear more than once. For example, here the 3 appears twice. Here the 2 appears twice. And like I said, we're going to use the array itself to map out which numbers we've seen by marking their corresponding index positions as negative. And we know in Java, indices start at 0. So for example, the first index is at position 0, and the last index in our nums array that has a size of 8 is 7. So what we're going to do is for every number that we're on, like 4, we're going to find the corresponding index of 4 is 3. So we're going to map 4 to its corresponding index, which is 3. And when we see a number like 4, we're going to mark its corresponding index, which we just found, 3. We're going to mark the number at that index to be negative. So if we see 4, we go to nums at 3, we mark it as negative. And the negative is basically going to mean that we've seen this number before, or this number has appeared before. Now, as we iterate through our nums array, some numbers, because of this process, might already be as negative. And to safely account for all the indices, what we're going to do is simply, when we're calculating our index, is we're going to take the math.absolute of the number that we're currently on before we subtract 1 from it. And in the end, some numbers are going to be positive. Those numbers mean that the index in which this number belongs to, that index plus 1 was never visited, was never seen, and it's missing. So let's code this out to see exactly what I mean, and then we'll go through an example to make sure it's all made clear. So in the beginning, we're going to create a list of integer. We can call this list, which is equal to new linked list. Now we're going to iterate for every int number in nums. We're going to calculate that index value, which I talked about. Int index is going to be equal to math.absolute of number minus 1. And now we're going to check if nums at index is positive. Then what we're going to do is nums at index is equal to negative nums at index. So like I said in the description, we're going to iterate through our nums array. For every number, we're going to calculate its corresponding index. So for example, 4, its corresponding index is 3. We're going to visit nums at 3, which is 0, 1, 2, 3, which is 7. If 7 is positive, that means we have yet to see the number 4. And so we're going to mark it as negative. And now our 7 is negative. So let's continue that thought process with the rest of our array. For 3, its corresponding index is 2, which is pointing to this 2. We haven't seen 3 yet, so we're going to mark 2 as negative. And then for 2, its corresponding index is 1, which is looking at 3. We haven't seen 2 yet, so we're going to mark 3 as negative. Then 7, its corresponding index is 6, which is pointing at 3. So we're going to mark 3 as negative. For 8, corresponding index 7, pointing at 1. Let's make that negative. Now for 2, we've already seen 2 before. So the corresponding index of 2 is going to be 1, 0, 1, but it's already negative. So we're actually going to skip this if block, and we're not going to do anything. We're going to keep iterating. So the next value is 3. Once again, corresponding index of 3 is 2, but 2 is negative already, so we're also going to skip it again, and we're going to reach the final number, which is 1. Corresponding index is 0. The number at 0 is 4, so we're going to mark it as negative because we haven't seen 1 yet. And so this is going to be our final list. If you notice, 8 and 2 are still positive. And if we check their corresponding indices, 0, 1, 2, 3, 4, and 5, what does that mean? If we go back to our int index equation, we're taking the number and we're subtracting 1. To get an index of 4, we're going to have to do x minus 1. And so obviously x is 5, but 5 does not appear in our array. And similarly, for 2, which has an index of 5, we would need a number 6, so we can get our index 5. 6 minus 1 is 5, but 6 also doesn't appear in our list. And so that's our final answer, 5 and 6. So now what we have to do is we have to loop through our updated array, look for any positive number, take the index of that positive number, add 1 to it, add it to the list, and do that for the rest of our nums array. Every time we have a positive number, take its index, add 1 to it, add it to the list, and in the end, we just need to return the list. For every int I equals to 0, as long as I is less than nums.length, I++, if nums at I is greater than 0, then list.add I plus 1. And then in the end, we just need to return list. So let's submit our code and see if it works. And there we go. So that was the find all numbers disappeared in an array problem on LeetCode. Like I said, it's arguably a medium question depending on the method you use to solve it. And I really hope you stayed to the end of the video and went through the example with me so we could really understand our code and the method or the approach we used to solve this problem, because the description in the beginning, as I explained, could be a bit vague. Otherwise, like I said, that was the find all numbers disappeared in an array problem on LeetCode. I hope you found that video helpful, and thanks for watching.